we just have to find the x within the question here. I'm just going to multiply each prize by its probability. So the first one is just 0. That's multiplied by 0.3. I'm just changing to a decimal just to make it look a bit easier. Then I'm adding on, so next one is 2 multiplied by 40%, so that's 0.4. Plus the next prize is x minus 10, whatever that is. And we're multiplying that by 0.28. Then plus x is the next prize. You multiply that by 0.02 because it's 2%. And then what it's saying is that the game is fair. So if it's fair, well then the expected value has to be equal to the amount that you put in, that it costs at the start. So that's €10. So we're just going to let all that equal to 10, and then we're going to solve for x. So 0 multiplied by 0.3 is just gone, that's just 0. That'll give us 0.8 there, plus 0.28x minus 28, 10 times 0.28, and then plus 0.02x is equal to 10. We can combine the x's. Actually, that should have been 2.8 in there instead of minus 28. That's a little small mistake. If I combine the x's, you'll get 0.3x. 0.28 plus 0.02 is 0.3, so 0.3x. I'm just going to move everything to the other side. So 10 plus 2.8 when you bring it over, and minus 0.8. And that just gives you 12 on that side is equal to 0.3 x, and then bring over the 0.3 and divide it. And then that's going to be, it's the same as times them by 10 and dividing by 3, so it's just going to be 40 in the end. So x is equal to 40 there. And that's all we out. This one is a mutually exclusive event. So if they're mutually exclusive, well then there's no overlap in the middle, so it's just one, and it's just two different ones like that. That's the way your Venn diagram would look. So there's no intersection, there's no overlap. Therefore, write down the value of P intersecting B. Well, there's nothing in it, so it's just going to be 0. And then the probability of A union B, well, it's just the probability of A is 0.1 and the probability of B is 0.4. So if you just add them two together, you get 0.5. And that's all. There's no working really involved in that question. It's just understanding what mutually exclusive events are. C and D are two other events with universal set U. Right. We'll let that be C and that be D. The probability of C is 0.5 and D is 0.7. What we want is we want the biggest bit out, the biggest possible amount on the outside. So what's the biggest possible amount that would be out there? If you're taking the intersection for a minute, if everything that's in C is also in D, so we'll just put 0.5 in there. If all of that is in D, so that's 0.7. Well, then there's nothing that can go. There's nothing that can go in here. So the smallest amount possible now is in here, and that would leave the largest amount possible to be out here. So if that were to be true, if it was 0.7, 0.5. Sorry, that wouldn't be 0.7 actually, that would be 0.2. And then nothing in the C bit. So now it checks out. So now the probability of C is 0.5 because everything in C is 0.5. The probability of D is 0.7 because you're adding those two together. So then we're leaving nothing in the just C bit. So therefore the bit on the outside would have to then be 0.3, and that's the most amount possible. Because if you put anything in C less D, then anything at all in there, that would reduce down what's on the outside. So the answer is going to be 0.3. The last part, why are these not independent events? Raining tomorrow and wearing a coat when you go outside. Well, obviously, if it's raining tomorrow, there's more of a probability that you're going to wear a coat. And that's all. That's the obvious thing here, and that's all you need to say. You could say as well that it depends on, so whether or not it is raining is going to affect whether or not you wear a coat. So that's the opposite of independent then. So independent is when things are completely free from each other, or just one thing does not affect the other thing. So here what the event E does affect the event F. So that's all